The history of cranes is a testament to human ingenuity dating back thousands of years to the dawn of civilization. In ancient Egypt, massive stone blocks weighing many tons were somehow lifted and precisely placed to form towering pyramids. These feats of engineering were accomplished with the help of early lifting devices, precursors to the modern crane. Evidence suggests that Egyptians employed a simple yet effective contraption known as the shaduf, essentially a large lever with a weight at one end and a bucket at the other. While the shaduf was more commonly used for irrigation, its basic principles of leverage were adapted for lifting heavier construction materials. The Greeks, renowned for their architectural marvels, further refined these early lifting mechanisms. They developed the compound pulley system, which used multiple ropes and pulleys to significantly reduce the force required to lift heavy objects. This innovation allowed them to construct magnificent temples and theaters that still inspire awe today. These early cranes, though rudimentary by today's standards, were instrumental in shaping the ancient world. They allowed civilizations to build bigger, bolder, and higher, pushing the boundaries of architectural possibility. The legacy of these early innovations lives on in the towering monuments and structures that continue to captivate and inspire us. Early cranes were crafted from the materials readily available in the ancient world. Timber, prized for its strength and abundance, formed the backbone of these early machines. Large wooden beams served as the primary structural elements, capable of withstanding the immense forces generated during lifting operations. Ropes, often made from hemp or flax fibers, were essential components, providing the means to hoist and lower heavy loads. The mechanisms employed in early cranes were equally ingenious. Levers, pulleys, and rollers were cleverly combined to create mechanical advantage, allowing relatively small forces to lift enormous weights. The Greeks, in particular, made significant strides in understanding the principles of mechanics, as evidenced by their sophisticated use of compound pulleys and other simple machines in their crane designs. These early engineers and builders, though lacking the mathematical tools and scientific knowledge of later eras, possessed a remarkable intuitive understanding of forces, motion, and equilibrium. Over time, as civilizations advanced and construction projects became more ambitious, the materials and mechanisms used in cranes evolved. Iron, with its superior strength, gradually replaced wood as the primary structural material, allowing for the construction of larger and more powerful cranes. The invention of the wheelbarrow and other simple machines further enhanced the efficiency of construction sites, enabling workers to move materials more easily and speed up the building process. For centuries, human and animal power remained the primary driving force behind cranes. Teams of men, often working in unison, would pull on ropes or turn large wheels to operate these massive machines. The rhythmic chants and grunts of laborers, straining every muscle to lift heavy stones into place, were a common soundtrack at construction sites in the ancient world. Animals too played a crucial role. Oxen, known for their strength and endurance, were frequently employed to haul heavy loads and power cranes. The transition from muscle power to mechanical power marked a significant turning point in the history of cranes. The invention of the steam engine in the 18th century ushered in a new era of industrialization, and cranes were quick to benefit from this technological leap forward. Steam-powered cranes, first introduced in the early 19th century, possessed far greater lifting capacity than their human-powered predecessors. They could lift heavier loads, reach greater heights, and operate with a speed and efficiency that was previously unimaginable. The arrival of the internal combustion engine in the late 19th century further revolutionized crane technology. Gasoline and diesel engines, with their compact size and high power output, proved ideal for powering mobile cranes, which could be easily moved around construction sites and used for a wider range of tasks. These innovations paved the way for the development of the modern cranes we rely on today. Throughout history, cranes have played a pivotal role in shaping our built environment, enabling the construction of some of the world's most iconic structures. The pyramids of Egypt, a testament to the ingenuity and engineering prowess of the ancient Egyptians, were erected using ramps, levers, rollers, and a considerable amount of human labor. While the exact methods employed remain a subject of debate among historians and archaeologists, It is clear that early forms of cranes played a crucial role in lifting and positioning the massive stone blocks that make up these monumental tombs. The Roman Colosseum, another architectural marvel that has stood the test of time, is a testament to the Romans' mastery of engineering and their innovative use of cranes. This massive amphitheater, capable of seating over 50,000 spectators, was constructed using a combination of human, animal, and mechanical power. Roman engineers developed sophisticated cranes that employed large tread wheels powered by teams of men to lift and move heavy stone blocks, columns, and other building materials. From the ancient world to the modern era, cranes have been indispensable tools for builders and engineers, enabling them to construct bigger, taller, and more complex structures. As we look to the future, cranes will continue to play a vital role in shaping our cities and our world, pushing the boundaries of what is architecturally and engineeringly possible.